ladies and gentlemen. Today we're going to talk about how an airplane flies. One of the main concepts that has to be clearly understood is that one of the fundamental laws of the universe is that energy cannot be created nor destroyed, and it can only be changed from one form to another. If we apply this concept to aerodynamic theory, we can imagine a streamlined flow of air that passes through a tube which has a reduced cross-sectional area here in the middle. So then mass flow will be the product of the cross-sectional area, A, times the velocity of the flow of the air, V, and this is P, which stands for rho, which would be the density of the air, but since we're talking about low supersonic speeds, so basically less than Mach 0.4, pressure changes do not really affect air density, so we can disregard and simplify the equation of continuity only as cross-sectional area times velocity is a constant, or velocity is the constant divided by area if we want to obtain velocity. So air mass flow will be constant across all points of the tube, and as we can see, if we have a reduced cross-sectional area here, so instead of being a cubic meter is only half a cubic meter, then the speed will be doubled, and instead of 52 meters per second will be 104 meters per second, and vice versa. Now we can talk about Bernoulli's theorem that clearly states that in a steady flow of fluid, of an ideal fluid, which is considered incompressible and has no viscosity, the sum of the pressure energy and kinetic energy is a constant. Kinetic energy is represented by half the density of the air times v squared, and this is pressure energy. So, for example, let's say that we have a static pressure of 100 and 1,325 newtons per meter squared, and a density of 1.225 kilograms per cubic meter, and a velocity of 52 meters per second squared. The dynamic pressure, the kinetic energy, will be 1,656 newtons per meter squared, and that gives us 102,981 newtons per meter squared, which you can see that is constant across the whole sections of the tube. Even though in this cross-sectional area where we said that velocity is going to increase, it has increased by double, but since we're multiplying by v squared, the value of kinetic energy has now risen to 4 times. And of course you can see that static pressure has decreased, but the total value is the same. So this is an airfoil which represents the profile of a wing. It's a specially shaped body that should remind you of a profile of a wing. And if we divide this image by 2, you can see that this represents the cross-sectional area of the tube that we were talking about before, so that we can remind ourselves that here this is an imaginary tube with streamlines, which represents the path of the particles of air, and here you're going to recall that the velocity increases and the pressure decreases. Here instead we have a positive pressure and lower velocity, and this pressure differential is going to act per unit area, acting and lifting the airplane up, creating this aerodynamic force that is called lift, and it directly opposes the force of weight of the aeroplane. And this is the whole concept of why an aeroplane flies. I hope you understood and enjoyed the video. That's it.